Okay, let's talk about the convolution theorem. If you have a function f multiplied by a function g, both of these functions are functions of t. In order to have it as a united form of solution in terms of t for both sides after doing the Laplace transformation, then you need to have the integral from 0 to t of f of t minus tau multiplied by g of tau d tau. The solution will be the Laplace transformation, or the Laplace inverse from a function of s to function of t for the multiplied functions in here. Now let's say we need to make the Laplace transformation for the function f multiplied by function g of s. The final form will be capital F of s multiplied by capital G of s. Now if you get the Laplace inverse for the capital F as a function multiplied by the capital G, this will give you the small f multiplied by small g in terms of t. Let's take an example to clarify that concept. Let's say we need to have the Laplace inverse for the following function. You have 1 over s multiplied by s minus 4 all squared. Now you want to find the f of t. In this case, we can identify we have two multiplied function in this case, so we can have an advantage of the convolution theorem in finding the solution for this problem. So first function 1 over s, the second function is g of s, equals 1 over s minus 4 all squared. As you can see, if you multiply f of s by g of s, you will get this. So that's how you know, oh, I can use the convolution theorem in here to find the final solution. Now we have f of s here. We can say f of t for this 1 over s, the f of t of it is 1. And if we want to have it for g of t, it's gonna be a little bit more long than the first one. So we're trying to get the Laplace inverse for the 1 over s minus 4 all squared. Okay, in this case it is t multiplied by e to the power of 4t. Now what if we want to get what's here, the Laplace inverse for the two functions? Laplace inverse of 1 over s multiplied by s minus 4 all squared. Okay, in this case we can say it is f of t multiplied by g of t, which is 1 multiplied by t e to the power of 4t. But to find the final solution, in this case, as we knew from the convolution theorem, this need to be having the integration from 0 to t, the f of t minus tau. We have a function f of t here is only 1, so you just keep it as 1, multiplied by g of tau. So anything in g of t, anything in terms of t need to be in terms of tau, which is in this case tau e to the power of 4 multiplied by tau d tau. Solving that will give you the final solution of your problem. So we have 1 over 4 multiplied by t. So here we have 1 over 4 multiplied by t e to the power of 4t minus 1 over 16 multiplied by e to the power of 4t plus 1 over 16. That is your final solution using the convolution theorem.